Okay, good morning. Hello, am I audible?
Yes, sir.
Okay, so let's start with another tool. The It is actually a special function rather than saying that it is a uh, tool for integration. So the name is error function. So just like gamma and beta, error function holds its own definition in form of integration. So I'll write down the definition. The definition is error function of x is defined as 2 upon under root pi integration 0 to x e to the power minus u square du, and is denoted as ERF of x. So whole of the chapter depends on this. So wherever we write down ERF of x, this means that this is equal to 1 upon 2 root pi integration 0 to x e to the power minus u square du. So this is what is to be remembered. So corresponding or depending on the error function, we also have the definition for complementary error function. Complementary error function denoted by ERF suffix C. So the C represents the complementary. In some books, it is actually directly written as ERFC. So this represents the complementary error function of x and is defined as and is defined as ERFC of x is equal to 2 upon under root pi integration x to infinity e to the power minus u square du. Yes, anyone, what is the difference between error function and complementary error function? Can you spot some difference here?
Limits.
Limits. So we know that the real line is from minus infinity to plus infinity. Okay, here it is minus infinity, here it is plus infinity, somewhere at the center is 0. So error function is defined for all the positive values, first thing. The next thing is, when you talk about the error function, integration is going from 0 to x. So if I am talking about error function of x, integration will be from 0 to x. and complementary error function will go from x to infinity. So this on this we have ERF, on this interval we have ERFC. Okay. So integrand is same for both of them, e to the power minus u squared 2 upon root pi. Just the limits are different. Fine. So we'll study some of the properties of this error function. First one, ERF of infinity. So these are small MCQs like properties. Okay. So MCQs can be asked on the properties. So first, ERF of infinity. By the definition, ERF is going to be 2 upon under root pi integration 0 to x. What is our x here? Infinity e to the power minus u square d. This will be ERF of infinity. How can we solve this integration? Anyone? Can anyone tell me how can we solve this integration? Sunidhi?
So maybe
Yes, yes. Please
put
speak up. Yes.
put minus u square is equal to t.
Minus u square as TE. Okay. Anything else? I think it is wrong substitution.
U is equal to root T.
Uh, please speak it again.
U is equal to root T.
Which means u square equal to t. Exactly. Why so?
Uh, because if we differentiate that U is equal to root T, then you will get du is equal to 1 by 2 upon root T into dt.
Okay, I'll write it down. So u square equal to t, which means that u is equal to under root t. So du is equal to 1 by 2 root t, which is 1 by 2 t raised to minus 1 by 2 dt. Limits are going to be same. If u is 0, t is 0. If u is infinity, t is infinity. So I'll write it down here. 2 upon under root pi integration 0 to infinity e to the power minus t raised to minus 1 by 2 dt, and 1 by 2, this 2 will get cancelled out with 2 in denominator. So what is the answer here? Can you solve this further?
Sir,
Yes,
it
Abhi.
becomes a beta function.
It is beta
So
function.
answer one.
Yes, exactly. But what is it? It is beta
Gamma
function.
one, sir. This
It is
integration.
Gamma function.
exactly. So this is a gamma function of half. So this is
Yes,
1
sir.
under root pi gamma of n plus 1. N is minus 1 by 2, so this is 1 by 2. Gamma of 1 by 2 is root pi, so answer this will get cancelled out and the answer is 1. So can someone tell me what is ERF of 0? Okay, by definition, ERF of 0 is going to be from integration from 0 to 0, 2 upon under root pi e to the power minus u square du. So what happens when lower limit and upper limit are same?
Zero.
So definite integrals in your 12th standard, you have seen that whenever the lower limit and upper limit becomes same, the value of the integration turns out to be 0. Third, ERF of x plus ERF C of x. Can someone tell me what will be the answer for this?
Sir, 1.
1. Why?
Sir, because they are complementary functions of each other, right? So this means that we are integrating from 0 to infinity. So, and we
Exactly.
have already done it. So the answer is 1.
Yes, very good. So 2 upon root pi e to the power minus u square du, and this is 2 upon under root pi e to the power minus u square du. So integrand is same, limit from 0 to x and x to infinity, and that's why this is 2 upon root pi integral 0 to infinity e to the power minus u square du. Just now we have seen that this answer is 1. And so error function of x plus complementary error function of x, the addition is 1, a very important property. A lot of MCQs can be solved using this. Fourth one, can someone tell me now what will be ERF suffix C of 0?
1.
1.
Sir, 1.
And ERF C of infinity
0.
0. So you can see that actually those are complements of each other. Next, error function of x is an odd function. What do we mean by an odd function? F of x is f of minus x is equal to minus of f of x. If this condition is satisfied, then we say that the function is an odd function. Now we need to prove that error function of x is an odd function. So what we will start with is ERF of minus x. ERF of minus x. So by definition, this is going to be 2 upon under root pi integration 0 to minus x e to the power minus u square d. So the substitution we need to make here is, I'll put u square, u equal to minus y, say. So du will become minus of dy. Later if u is equal to 0, then y is also 0. If u is equal to minus x, then y turns out to be x. So if we substitute this in the above integration, we'll have 2 upon under root pi integration 0 to x e to the power minus y square. What is du? Du is minus of dy. So minus sign comes outside, 2 upon under root pi integral 0 to x e to the power minus y square dy. So we can see that this thing is nothing but the error function of x. So this is minus of ERF of x. So what we have proved is the error function is an odd function. Okay. So again, this property can be used to solve many of the examples. Most important theory examples, those have been in study in error function are finding out the derivatives of error function, finding out the integrations of error function. So we'll look at it, but before that, I'll just try to plot the graph of this. So if you think of the graph of this error function and the complementary error function, so how we are going to get is at x equal to infinity, you can see that for the error function, it turns out to be 1. At 0, it turns out to be 0. So it will start from infinity, come at 0, again it will go from what you say, from 0 to it will go to plus infinity. So the graph, if we actually try to plot it, so if this is the point 1, so from infinity comes to 0, actually for minus infinity is not defined, so I shouldn't do this actually. When it, this is the graph of ERF, whereas for the complementary error function, at 0 it is 1, this is the value 1, and at infinity it turns out to be 0. So this kind of graph we have for complementary error function. Fine. So this was just extra knowledge actually. I'll go for
Sir, I had a doubt.
yes.
Sir, in the graph,
Hmm.
how did you decide that the tangent is the x-axis?
Oh, tangent is x-axis at infinity, asymptote. So asymptote, you can try this. It will be a good exercise. Take the error function of x and what happens when x tends to infinity, right?
Sir, and negative values, the graph does not exist, right?
Yes.
Negative values of x, the graph
Yes.
does not exist.
Yes, exactly. So that's why I didn't draw it on the left hand side. If you take x as negative, what will happen is your integration will go from 0 to a negative number. It's quite absurd, right?
Yes.
Yes. Next, show that d by dx of ERF of AX is equal to 2a e to the power minus a square x square upon under root pi. So I'll write it down, d by dx of ERF of AX. This is equal to d by dx of 2 upon under root pi. Integration will be from 0 to AX e to the power minus u square du. How do we take the derivative here? How do we take the derivative? Anyone?
the rule 2 of DUIs.
Exactly. So by DUIS, rule number? Rule 2. You can see that the integration is with respect to u, right? And the parameter here is x. So what will be the integration? 2 upon root pi being constant will come outside in bracket. Integration 0 to ax d by dx of e to the power minus u square du plus what we have to do is in the integrand you put the upper limit, so e to the power minus of ax whole square into, by chain rule, the derivative of upper limit d by dx of ax minus, then you put the lower limit e to the power minus 0 square into d by dx of 0, bracket complete. What is this term? What is the derivative of e to the power minus u square with respect to x?
0.
0. Since derivative with respect to x, so u will be treated as constant, so plus 0. In the second one, derivative with respect to x, so that will be a into e to the power minus a square x square. What about the third term? It is 0. So this is 2a e to the power minus a square x square upon root pi. Look, here this formula we have derived it for general, right? So if someone asks you what is d by dx of error function of x, can you tell me orally now for this?
0.
No. You are not relating this. This is the formula that we have done for general thing, and now I am saying that find d by dx of error function of x.
So 2 into e to the power minus x square upon root pi.
Yes, exactly. So what change we are doing is we are just putting the value of a as 1. Similarly, someone can ask you error function of 2x. So all those particular cases are covered in this. If you know this formula, you can give the derivative for any of the error function or anything. Fine. Next example. Show that integration 0 to t ERF of ax dx is equal to t error function of at plus 1 upon a under root pi e to the power minus a square t square minus 1 upon a root pi. So let's consider our LHS. LHS is integral 0 to t ERF of ax. Let's consider it into 1 dx. What is the choice of u or v? Look here, Lied rule won't work. So you will have to think in a manner whose derivative can be found out, whose integration can be found out. तो जिसका डेरिवेटिव ले सकते हैं दैट इज यू। तो अब कहोगे कि डेरिवेटिव तो दोनों का ले सकते हैं हम, ERF of AX as well as 1. So if you take the derivative of 1, both the terms will become 0. Want that. So what I'll say is, let's consider this as u, this as v. So when you're integrating u, integration of v, that will become x, limits from 0 to t, minus integration 0 to t d by dx of u, which is ERF of AX into integration of v, which is x dx. If you solve the first bracket, what do you get? ERF of AT into t. When you put the lower limit, everything turns out to be 0. So I will leave that. Integration 0 to t. Derivative of error function, I'll go back to the previous page. So 2a e to the power minus a square x square upon root pi. So 2a e to the power minus a square x square upon root pi into x dx. So constant terms we can take outside. Minus 2 upon under root pi. A I'll keep inside. Integral 0 to t e to the power minus a square x square 2ax dx. Yes, tell me, how can we solve the integration? I'm sorry,
So it is only AX, right?
yes. What was the question? How can we solve the integration? It's an easy integration. I don't think it is that much difficult. Yes, Anand.
Yes, sir. A square x is equal to t.
A square x equal to t. Okay. I don't think so.
So
Yes, sir.
x square is equal to 3, multiply and divide by a.
Yes, exactly. So a square x square I want to put as t. Look, the basic rule when you learn integration in your 12th standard is what you do is you adjust the derivative of the substitution in the given equation. Say if I want to solve integration, the most basic example, say cos x upon sin x dx. So what you do is you see that the derivative of this is present in the numerator. And whenever this kind of substitution examples are there, the basic idea is you adjust the derivative and then you get the answer. So here I can see that a square x square is there, whose derivative is going to be 2a square x. So 2x a is already there, so I just need to adjust a there. So I will multiply and divide by a, so this turns out to be a square. Moreover, there is a minus sign, so I will make this plus and I will keep here minus sign. So now what we observe is you can see that the derivative of minus a square x square is minus 2a square x dx. So the things for substitution are almost ready. So I'll write it down here. So minus a square x square equal to t. So minus 2a square x dx will become dt. So if x equal to 0, then t equal to 0. If x is equal to t, oh, I'm so sorry, I've done. So a square x square has to be u. So this will be du equal to 0. If x equal to t, then u equal to whatever. So let's not get into that. So this turns out to be integration of e to the power minus t. So when we have e to the power at bracket complete dot d plus 1 upon a under root pi in bracket integration of e to the power minus u will turn out to be minus of e to the power minus a square x square integration from 0 to t. So this is equal to t erf of at plus when you put the upper limit and when you put the lower limit. So when we put the upper limit, that will be minus 1 upon a root pi e to the power minus a square t square plus when you put the
That will be plus EH, a plus there in before. In that you done a e power a minus a minus a minus a square x square.
yes, exactly.
Yeah.
Yes, thank you. So this will be plus 1 upon a root pi e to the power minus a square t square. This will be minus the lower limit 1 upon a root pi e to the power 0 will be 0. So this is the same expression that we required. Next, integrate show that the theory examples actually show that integral 0 to infinity e to the power minus x square minus 2bx dx is equal to under root pi by 2 e to the power b square in bracket 1 minus erf of b. So let's start with the integration. I is equal to integral 0 to infinity e to the power minus x square minus 2bx. Look, what we need to get is e to the power b square, right? And that I can get only if there is a b square in the power. So what I'm going to do here is I'll subtract b square and add b square. So what this will give me, this is going to be integral 0 to infinity e to the power minus of x plus b whole square into e to the power b square. Please check the calculations. So e to the power b square being constant can come outside. integral 0 to infinity e to the power minus of x plus b whole square dx. So to convert this to an error function, what we are going to do is we will put x plus b as say t. So dx will become dt. If x equal to 0, then t equal to b. If x equal to infinity, then t turns out to be infinity. So if we substitute this here, what we'll get? E to the power b square integration b to infinity e to the power minus t square dt. What adjustment more I have to do? So if I want to call this an error function, what I will have to do? Multiply and divide by 2 upon the root pi.
Root pi. Yes, sir.
So root pi by 2, 2 upon under root pi integration b to infinity e to the power minus t square dt. So if we look at the bracketed term, that is complementary error function of b. But complementary error function of b is nothing but, we have seen the property ERF of b plus ERF C of b. The addition is 1. So ERF C of b is going to be 1 minus ERF of b. This is what was required. Next, show that ERF C of minus x plus ERF C of x equal to 2. So complementary error function of minus x plus complementary error function of x. This is 2. What do we know? We know that ERF of x plus ERF C of x. This is 1. And we need to show this. Okay. So I will start with this property that we have. So ERF of x plus ERF C of x. This is 1. So I'll replace x by minus x throughout this equation. So ERF of minus x ERF C of minus x. This will also be 1. So addition is 1 for all the x. So it will also be true for minus x. Then we know that error function is an odd function. So this will turn out to be minus ERF of x, right? Plus ERF C of minus x. So which means that ERF C of minus x, which is equal to 1 plus ERF of x. Look what we have derived. So complementary error function of minus x is equal to 1 plus ERF of x. So I'll start with the LHS now. What is our LHS? ERF C of minus x plus ERF C of x. So I'll put the value. ERF C of minus x is 1 plus ERF of x plus ERF C of x. But what is this addition? This addition is 1. So the answer is equal to RH. Fine. The last example, and then we'll end.
Sir, you can show that slide again.
Okay.
Sir, done.
So show that integration a to b e to the power minus u square du. This is equal to under root pi by 2 error function of b minus error function of a. Okay, this is what we need to show. We need to find the value of this. So I'll start with error function of infinity. As you can see that this equation involves all of these things. So when I'm saying error function of b, it will start from 0. So it will go to b. Error function of a is 0 to a. And the middle part a to b is also covered. So this is small construction that we need to do. So when we say error function of infinity, this is 2 upon under root pi integration 0 to infinity e to the power minus u square du. The error function of infinity is 1. This we know. I'll break that integral on the right hand side as integration 0 to a e to the power minus u square du plus 2 upon under root pi integration e to b e to the power minus u square du plus 2 upon under root pi integration b to infinity e to the power minus u square du. So 1 is equal to, what is this? This is error function of a plus 2 upon under root pi e to b e to the power minus u square du. And this is,
Complementary error function of b, which can be written as 1 minus error function of b.
yes, exactly. This can be written as 1 minus error function of b. But before going to that, as I need this equation, I'll keep this on this side and send everything on other side. So 2 upon under root pi integration a to b e to the power minus u square du. On the right hand side, we will have 1 minus ERF t of b minus ERF of a. So 1 minus ERF of b will be ERF of b. So a to b e to the power minus u square du 2 upon the root pi will be under root pi by 2 in bracket. The first term is ERF of b. The second term is minus ERF of a. Fine. So this is the end of error function. If you have any difficulty, you can ask.